All right, hi guys. Happy Wednesday. This is our November week 2. Okay, hi the two of you. Hi Jala, hi Shaira. Shaira, you were absent last week, right? If I'm not mistaken. Just to check with you, were you absent last week or were you not? Because I think you were absent, right? Okay, so Shaira, if you're absent, right? Please don't forget to request your video. Can you see the link there? Can you click into the link, fill up the form so that I can send you the video for last week? Okay, it's a replacement video. I'll send you the video for last week. And please don't forget to watch. Okay, please fill out the form. Don't forget. Okay, guys, we are going into our revision again. Okay, we stopped around here. Okay, last week we did go into our periodic table, remember? We stopped here. Okay, we finished our periodic table revision. And today, we will learn about isotope. Okay, today we'll learn about isotope. Guys, do you remember what is an isotope? Do you remember what is isotope? Okay, isotope is the same element with the same proton number, but different neutron number. Okay, just so that you don't forget, let me repeat this whole thing. Okay, inside an atom, there are some blue color balls and there are some yellow color balls. Okay, so this is the nucleus of an atom. Okay, the blue color ball, we call it proton. Okay, I use color because it's easier to imagine. The yellow color ball is called neutron. Okay, so the total number is what we call nucleus or nucleon number, if you remember. All right, so the proton number, the blue color ball, and the neutron number, the yellow ball. All right, so the nucleon number, the total number is these two adding together. All right, you can ignore electron because, as I said last week, guys, proton and electron is always the same. Because no matter how many positive I have the same amount of negative. Do you remember? Do you remember? Okay, if I have one proton means I have one electron, assuming it's an atom, assuming it's neutral. Okay, that means how many positive I have how many negative. All right, so guys, isotope means they have the same proton number but different neutron number. Right? Proton number is the IC number. Just write this down and or put it into your head. Proton number is the IC number. Let's say IC number 1. IC number 1. IC number 1 is always hydrogen, nothing else. All right? All right? It's just like, I'm sure guys in your class, your school class, you have your name list, and let's say you have a number. All right? Let's say your name is, your name starts with N, then your number should be around 20. Let's say you're number 20. In that list, you're number 20. 20 is for sure you. It's no one else, right? So in this case, 1 is hydrogen, no one else. Okay, if they have the same proton, they must be the same element. All right, but in one element, you have 3 guys. They are like clones, right? Imagine you have 2 clones of yourself. All right, you have 2 people that looks exactly the same like you. You guys are the same person. Okay, it's just that you guys have a little bit difference in the neutron there. Okay, so let me repeat this again. Isotope is same proton number, but different neutron number. Or nucleon. Okay, when I say nucleon is okay. Okay, same proton number, different neutron number. Are you okay with this, guys? Are you okay with this? Same proton number, different neutron number. And this number here is the nucleon number. That's the total. Can you see? 1 plus 0, 1. 1 plus 1, 2. 1 plus 2, 3. That's the nucleon number. Okay? Shara, do you have any idea of this? Since last year you were not here. You were not in my class. Have you learned this last year? Do you have any idea of this? Yes, huh? Okay, that's good. Okay, so again, guys, isotope, same element, same proton number, different neutron number. Okay, and there are some isotopes I want you to know. Kind of forgot, it's okay. Right, there are some isotopes I want you to know. Okay, I'll highlight these few first. Sodium 24, iodine 131, phosphorus 32. Okay, these three, why do I group them together? Because they are tracers. Okay, tracers. Okay, what is a tracer? What is a tracer? Let's say now I want to follow you home. I want to follow you home. What do? I put a GPS device under your car so that the thing follows you home. I know where you stay. That thing is a tracer. So something like a thing to follow things around. I use a tracer to follow you around. Same thing here. Sodium 24 is to follow blood clot, to follow the blood clot in your body, see where you have blood clot. Iodine 131 is for thyroid, to follow whether you have thyroid problem. Phosphorus 32 is for phosphate in plant, fertilizer in plant. Okay, phosphorus is the fertilizer. So plant, we can use this to see whether a plant is absorbing fertilizer well. We trace the fertilizer in the plant. This one, we use to trace blood clot. This one, we use to trace thyroid. This one, we use to trace fertilizer. So you see, they have the same function, is to trace things around, to see where are they going, to see whether something is absorbing well or not. Sodium 34, iodine 131, phosphorus 32. All right, so and then the next one is the killer, cobalt 60. Okay, this cobalt 60 will make gamma ray. Okay, and another here. So we use it to kill cancer cell. We use it to destroy bacteria. It's a killer. Okay, it's a killer. And then we have carbon 14. This is for carbon dating, to see whether a fossil, how old they are. Okay. So nothing much here to say actually. Uranium 235, this is for power station, for nuclear. Okay, we will revise on chapter 12. Form 4, don't worry. That's your fission and fusion. If you remember, are there? Fission is your uranium 235. We use this in our power plant. Okay, guys. Okay, this is pretty easy. This is pretty easy. Don't get this part wrong. Okay, so guys, shall we go into our exercise? Right, guys, I will try to lead you on. We will do one, discuss one, lead you, do one, discuss one, and we'll see. Okay, let's go to question 7. Okay, let's go to question 7. Okay, guys, let's go to question 7. The table below shows the number of protons and neutrons present in the atom X and Y. If you remember, proton is the blue color ball, neutron is the yellow ball. Okay, so the letter issues are not actual symbol. Okay, this one don't care. That means we have 2 atoms here, X and Y. Okay, do you remember what is the nucleon number? Guys, do you remember what is nucleon? Nucleon is the total number. Yellow ball plus blue ball. Remember? Yellow ball plus blue ball. So the total, easy law, for X is 11 plus 12, so 23. For Y is 17 plus 18, so 35. Okay, guys, do not get this wrong in exam. Please, don't get this wrong. Because it's so, so not worth it to get it wrong. Okay, draw the electron arrangement for atom X. Guys, let me ask you, electron arrangement follow who? Electron will follow neutron or proton? Follow which one? Follow which one? Any idea? Any idea? Which one do we follow? Which one do we follow? Electron is the negative. Electron is the negative. So the negative will be always same as the positive. Right? So if X has 11 positive, I will have 11 negative, 11 electron. So how do you arrange 11? If you remember, this is from last week. Okay, 11 is 2.8.1. That means first shell, they put 2. Second shell, they put 8. Third shell, they put 1. All right, and if you remember this, we drew this last week, sort of. Remember this? So guys, use X. Okay, because X is easier to see for your electron. So 2, 8, 1. Okay, remember when you draw, it's pair by pair. You see 1 pair, 1 pair, 1 pair, 1 pair. For the first shell, 2 is like opposite lah. Okay, and then the third shell is 1. Right, guys, do you remember what we learned last week? Do you remember what we learned last week? Is X a happy guy? Is X happy? 281. Is he happy? If you are X, you have 281. Are you happy? Are you stable? Are you happy? Jella, you were here last week. Do you remember? Is X happy? No. So what will X do? What will X do? If you are X, what will you do? You have 1 here. How do you make yourself stable? How do you become perfect? How do you become full? Very easy. So you just take this one, you throw it away. Remember? Remember? Okay, so your X ion, if I throw this away, now I become positive. Because I throw one negative away, I become positive. So now I'm a happy guy. Now X is happy. When X throw this one electron away, X will be happy. Now this is this is ion X now. Why ion? Because positive is ion. Okay, so they don't want ion, they want atom. They want atom. Atom means the normal form. Okay, the one without donating or accepting. So this is your X. Okay, guys, are you guys cool? Are you guys cool? Jella, Shara, are you guys okay? Before I move on, this part is very important, especially the drawing part. Okay, good, good. If you understand that, okay. Right, moving on. X will, there you see they're asking already. X will form a positive ion. State the number of electron. Okay, just now X has 11. When X throws 1 away, X will become 10. Okay, you must see, so I cannot write 2.8, man. They only want the number of electron. They don't want electron arrangement. So we don't bother lah. We just put 10 lah. Okay, 10 will do. Don't need to go overboard. Okay, D. Chlorine is a chemical element that has a proton number of 17. Where is the position of chlorine in the modern periodic table? Okay, guys, how do we arrange 17? Can both of you tell me? Just now 11 is 281. Now 17 is how? Come, answer. Let me have your answer. Let me have your answer. Just now 281. 11 is 281. What about 17? What about 17? Guys, easy question. What about 17? 287. Good. Good. 287. Okay, so how do we tell where is it? How do we tell? Okay, let us say the group first. Where do you think 287 is in terms of group? We have group and period, right? Okay, kumpulan and color. Okay, which group is it at? Shara, you're doing it in English or BM again? Sorry, I couldn't remember. Which language you're doing it again? Oh, BM. Okay, so kumpulan and color lah. Okay, so how do you tell? Okay, how do you tell? Guys, very easy. If, okay, this outside guy, the most outside electron is called valence electron. If you remember, in BM it's called electron valence. Okay, so the valence will tell you what group is it at. If I am 1, I am at group 1, kumpulan 1. I think I told you this last week. Okay, let us go back again. Okay, if I have 1 on the outside, group 1, kumpulan 1. If I have 2 outside, group 2, kumpulan 2. And pay attention, pay attention. Outside got 3, not group 3, not kumpulan 3, is group 13, kumpulan 13. We skip 3 to 12. We skip 3 to 12 because these are called transition metal. Logam peralihan. Okay, peralihan. So we just alihkan, so we don't care. Okay, and then the rest just continues lah. If I have 4, kumpulan 14, group 14, 15, 16, 17, 18. Okay, so 18 is the happiest guy. This guy is very happy. You see, very happy. 2.8. 2.8, you see, 8 also very happy. These two, they are the same group. Very happy, very satisfied. They are already full. Okay, the valence sudah penuh. Also very happy. Okay, so this 287, 7 means is in group 17, kumpulan 17. What about the period color? You just look at the shell. See, how many layers here? 1, 2, 3. 3 layer, 3 lapis. Okay, 3 lapis. 3 layer means this is in period 3. Okay, color 3. All right. So chlorine is in group 17, period 3. You don't believe me? You go periodic table, you know. Okay, where is chlorine? Chlorine is here. You see? Group 17, kumpulan 17. Period 3, color 3. There. So you can't lie on this thing. Easy, Easy, Guys, don't get this wrong in exam, please, Easy, Okay, guys, can you please try question 8? Can you please try question 8? We'll do one by one today. Okay, we'll do one by one today. Okay, can you please try question 8? I'll give you 5 minutes. 5 minutes. Okay, you do, then we discuss. Then we jump to another one. Okay. I'll give 5 minutes. Let me know in the chat. Please type OK when you are done. Please type OK when you are done. Don't wait for my answer. If you don't practice, you will never know. You will never get it. Okay, so please do it now. Right, are you guys done? Are you done? There's only 5 questions here, shouldn't be very long. Are you done? All right. If you have problem doing this, let me give you a hint. Right, whenever you see numbers, the bigger number is usually the total. That means the nucleon. Blue plus yellow ball. I mean, it makes sense, right? The total number is usually the bigger number, right? And then the smaller number is usually the IC number, which is the proton. Why? Because IC is important. We don't write neutron here because we don't deal with neutron. We just leave it aside. If you really want to know the neutron, just minus lah. Okay, because this is the yellow plus blue ball. And then this is the blue ball. So to find the number of yellow ball, minus lah. Take the total minus the blue ball, then you get yellow ball lah. Okay, are you guys okay? Did you guys finish, or you guys are halfway doing? Or you just have no idea how to read this? Guys, any problem you're facing, please let me know. If you can do, then let me know too. If you cannot do, which part you are not okay, please don't be shy. Let me know. All right, so define nuclear number. What is nuclear number? Nuclear number is sum of proton number and neutron number. Okay, hasil tambah nombor proton dan neutron. Right, total ball. Total ball. The nombor proton is your blue ball. Neutron is your yellow ball. So it's adding 2 together. Right, the electron arrangement for X and Y. Electron arrangement, we just follow the proton. Okay, we just follow the proton. Because electron, proton same, right? Positive, negative, same. Okay, how do you arrange X then? How do you arrange X? Guys, what's your answer here? How do you arrange X? X has how many electron here? Can someone answer me? Can someone answer me? What's the number of your proton? That's 2, isn't it? So if I have 2 proton, I will have 2 electron. Correct? So how do we arrange 2 electrons? How do we arrange 2 electrons? Very simple, just 2. First shell full. Okay, first shell full. And then for Y, how do you arrange 16? 2, 8, 6. 2 plus 8, 10. 10 plus 6, 16. So 16 lah. How do you arrange Z? They didn't ask for Z lah, but we'll tell them anyway. So this is 2.8.7. Cos 17. We did this just now. Same. All right, guys. Can you answer? Can you tell me something? Can you tell me something? 3 guys here, X, Y, Z here. Who is the happy one? And who is not happy? Who is the happy one? Who is the satisfied one? Who is the full one? Who is it? Anyone? X, Y, Z. Who is the happy one? Or there's no one? Or there's all 3? What do you think? Yes, X is the happy one. Why? If they ask you this in an exam, X is stable. Why? Balance. Why is it balanced? Okay, it's not balanced, it's full. Okay, this is what we call duplet. Remember? Because the first shell is full, right? The first petala is already penuh. petala yang penuh. So they no need to take any more. Oh, it means stable. Okay. Okay, cool. Right, so X is very stable, X is very happy. Okay, and then Y and Z, they are not very happy. Why? Because Y, she needs two more. Right? Z, she needs one more. All right. So in this case, right, Z is the gila one. Z is the gila one. Imagine if you are 1 mark away from perfection, compared to someone with 2 marks away from perfection, you will be more crazy. Right? Right? If you score 99 in exam, you will be more upset than the 98 guy. Because one more mark, satu markah je, then you get full already. But the 98 guy is like, nee, there's two more, never mind lah. Okay, because it's further away. So this guy is gila. Okay, just like the one. See, this guy is so gila. Like, I just need to throw one more, I'm perfect. So X will be crazy. Same goes to this guy, also crazy. Okay, so the number of electrons present in the atom of X. Okay, that means they ask you X has how many electron. Okay, we just answer it, right? Okay, it has 2. Right? Number of electron is 2. Explain, because it has 2 proton. It has 2 proton. Or you can say same number of proton and electron. Both answer accepted. Okay, terdapat X terdapat 2 proton atau nombor proton dan elektron yang sama. They have the same number. All right, proton and electron is always the same. Positive, negative, always the same. All right, so D state the number of neutron are the yellow ball present in the atom of element Y. Explain how the answer is obtained. So guys, how do you get the number of yellow ball here? How do you get the number of yellow ball for this guy? You just take the total number minus the blue ball, isn't it? Total ball minus blue ball, you get yellow ball. Guys, this is just kindergarten logic, right? You don't tell me you don't understand. Okay, so 32 minus 16, you get 16. So 16 neutron. So which atom will form ion? Who will take electron or throw electron? Very easy, like I said, Y and Z, these two. So explain the formation of ion. Okay, so Y. Okay, let's just take Y lah. Okay, Y, she is very unhappy. Okay, because she is 286. Okay, she's 286. Guys, pay attention how I draw 6. 1, 2, 3, 4, 5, 6. You fill up, down, left, right. Then you fill up, down, left, right. Please don't do this. Guys, if you do this, 1, 2, 3, 4, 5, 6. This is empty here. Your answer is wrong. You have to fill up, down, left, right. Up, down, left, right. Okay, you have to do this. Don't ask me why. That's the reason. Okay, so what do? What will this guy do? This guy will accept 2 electron. Menerima 2 electron. So that Y can become 2, 8, 8. Okay, so if I take 2 electron, I will become 2 negative. Okay, this means I took 2 electrons. Because electron is negative, right? I take 1 negative, I become 1 negative. I take 2 negatives, I become 2 negative. Okay, so Z, if you want to do Z, is the same. Okay, let me draw Z. I just draw the outer shell. Z, the outer has 7. So Z will accept 1 electron. So Z will become full outside. Okay, and then this is negative. Okay, either this or this. You have two answers. You have two answers. So up to you lah. See which one you want to write lah. Both cases are accepted. Guys, are you okay? Jella, are you okay? Jella, you still there, right? Just to check on you. Are you okay? Okay, good. Okay, we move on. Okay, let's see which one I want to do. Okay, I'll do one more for you, and then later I'll let you do another one. Okay, let's go to 32. I don't know why the number just jumped to 32. Don't ask me why. Okay, page 9. Okay, again, proton number. This is the blue ball. Nucleon number. This is blue and yellow. Okay, blue and yellow ball. So this is the total. This is the blue. So how do we get the yellow ball? This one minus this one. There they're asking for already. Determine the number of neutron. Neutron is the yellow ball. So how many yellow balls here? So 27 minus 13. So 14. 35 minus 17. 18. 40 minus 20. 20. Okay, easy. Next, electron arrangement. Electron, again, we follow proton. So how do you arrange 13? 2, 8, 3. How do you arrange 17? 2, 8, 7. How do you arrange 20? 2, 8, 8, 2. This one a bit special because this one got 4 shells. 4 petala. So this guy should be in period 4. Color 4. Group 2. Kumpulan 2. So you draw yourself, You draw yourself. I'm just going to draw the outer shell for you. The outer shell. This one got 3. This one got 7. This one got 2. Okay, so you settle yourself lah. You pandai yourself. Okay, so where are the elements X, Y, Z located? This is just now what we did. Okay, so this guy has 3 valence. So group 13, kumpulan 13. Remember, there's no 3, 1, 2, 13. 3, 12 we skip. And then we got 3 shells. So this is period 3. Okay, color 3. Okay, of course, in BM is kumpulan 13, color 3. Okay, I'm just going to write the English here. So 7 is group 17, period 3 also. 2 is group 2. And then I just mentioned the answer, period 4. Kumpulan 2, color 2. Kumpulan 2, color 4, sorry. Why I say 2? Okay, 4. Okay, so how do the atoms of the following elements achieve stable? How do they become stable? How do they become happy? How do this guy become happy? Okay, this guy will throw this 3 away. So donate 3 electrons. Menderma 3 electron. What about Y? Y is 7. So Y will accept 1 electron. Menerima 1 electron. Alright, so if I have 1, 2, 3, I will donate. If I have 5, 6, 7, I will accept. Easy. Okay? Throw 1, throw 2, throw 3. Take 3, take 2, take 1. Then what about 4? 4 will throw 4 or take 4. This one we don't learn because 4 is like middle. 8 don't do anything. 8 they don't do anything because 8 already happy, already full. They won't take or they won't throw. Okay, easy, Easy, Right, guys. Can you do 12? Can you try 12? This is a bit tricky. This question is a bit hard. So why not you try 12? Now, I'll give you also 5 minutes. Okay, try now. All right, are you guys done? Sorry, my PC just crashed. I have no idea why. My Zoom just crashed. All right, I'll give the answer here. Please check. Electron arrangement for P and Q. Okay, I already said electron, we follow proton. Alamak, the answer just keeps repeating. So P is 2.4 plus 6 what? So P is 2, 4. Remember I said you draw up, down, left, right first. And then for Q is 8. 8 is 2.6. So 2.6, 2, 3, 4, 5, 6. 2.6. Okay, so elements P and Q, so there's no need for ion. If they ask for ion, then we need to take 2, then we need to add this, 2 minus, no, they didn't ask for it. So read the question properly. Name element R and give the ion of R. Okay, what is R? 17. This one you need a periodic table. 17 is 287, which is group 17, period 3. This guy is chlorine. How do I know it's chlorine? Because I've done this so many times. Okay, you might not know it. Just look at the periodic table. Okay, ion of R, it will become R minus, because chlorine will take 1 to become 288. So when I take 1, I become negative. Right, position of R. R is in group 17, period 3. Kumpulan 17, skala 3. Because this guy has 7 outside, 3 layers. Okay, so 17 and period 3. Okay, and then P has isotope. Just to let you know what is P, P is carbon. Carbon 12, normal carbon. What is another isotope of carbon? Do you remember? Okay, what I meant by isotopes? Okay, they are the same element with the same proton number but different neutron number. Okay, unsur sama yang mempunyai nombor proton yang sama, nombor neutron yang berbeza. Alright, so name isotope P. Isotope P would be carbon 14. Remember? Carbon 14. Now, what is this for? This is for carbon dating. If you remember, or if you cannot write carbon dating, just say determine age of fossil untuk menentukan usia fossil. How old fossil is? Is it 2 million years old? Is it 3 million years old? Is it 10 million years old? You just look at the carbon 14. Okay, simple, guys. As you can see, the question just keeps repeating. Okay, you see electron arrangement and what? It just keeps repeating. It's the same answer again and again. Okay, so as the last part, let's go and do this, shall we? Let's do question 14. All right, I don't want you to pay attention here, pay too much attention here, because you just need to agak-agak know. Okay, carbon 14, what is this for? Age of fossil. Okay, phosphorus 32, this is a tracer for plant. We trace how plant absorb fertilizer. You see, metabolism of phosphorus in plant. Iodine 131, it's for your thyroid tracer. This is for your cancer, thyroid cancer. Your cholangia thyroid. This is to produce thyroxine, remember? Your metabolism. Cobalt 60, this is to produce gamma, to kill bacteria, to kill cancer cell. Uranium 235 is to generate electrical energy, nuclear energy. This one not important. Americium 241 is to measure paper, thickness of paper, not important. These 5 are the important ones. Like I said just now, the one I circled for you, those are what you need to know. Okay, it's like almost everything lah, but some of it is not important. Okay, next, radioisotope P and Q. Okay, what is P doing? Guys, this is not MRI. This is not MRI. This is actually radiotherapy. Radiotherapy, where they use gamma ray to kill your tumor. Okay, gamma ray to kill tumor. So what do we use? We use cobalt-60. All right, cobalt-60. And Q obviously is a fossil, so we use carbon-14. Easy. Effect of nuclear explosion, you will produce radioactive radiation. Okay, sinaran, radioactive. You can say it causes cancer, right? It causes cancer, things like that. Number 3, what is the material used to make containers for keeping radioactive substance safely? We will use lead. In BM, we call it plumbum. This is the thing that will stop radiation, stop all radiation. Okay, guys, I'm not gonna go too much here. Let's do this also. If you remember, this is your power station. What is the radioisotope we use? We use uranium-235. Okay, uranium-235. And then energy generated, this is your nuclear energy. The Naga nuclear. Right, I don't need to go crazy here. I think that's pretty much it. Guys, do you have any more question about this chapter? Do you now understand what is nucleon, proton, and neutron? And of course, electron. How do you draw the arrangement? Do you? And how do you arrange your periodic table? Do you remember? If you can understand most of the thing I say, then this chapter, it's pretty much that. Guys, this chapter is confirmed coming out for your trial, confirmed coming out for SPM. It's just that it's more or less. It could be paper 1 or paper 2. If it's paper 2, then you untong lah, because something like this will give you a lot of marks, right? No long answers needed, but it will give you a lot of marks. Okay, so guys, I think I'm gonna end it here. Right, if you have no question, then I will call it a week lah. Cheryl, I did send you the replacement video to your email. Please check your email. Okay, and I will see both of you next week. Okay, happy Wednesday. I will see you soon. Right. So guys, take care. See you next week. And bye-bye.